These are a couple of American Power Conversion Smart-UPS 1400 uninterruptible power supplies. These came from the television station, and my job today is to check these things out, see if they work, and I have some new batteries I'm going to stick in these because we need to put at least one of these into use. We recently set up a new character generator at the station. It's a pretty neat system. It's about 10 years old, and it's basically a massive 60-70 pound dual AMD Opteron rack mount computer that has some specialized expansion cards installed in it, and it can do some really cool 2D and 3D graphics. We recently got it working again. The power supply blew a couple of years ago, and we're just getting it back running now. But the thing draws a ton of power, so much so that plugged into the Smart-UPS 1500 in the editing room at the station, which has a couple of other computers and the Betacam VCR plugged into it. When that character generator is running, the UPS shows a warning that it has less than 5 minutes of reserve capacity, meaning that if a power were to go out, it's only going to hold the load for less than 5 minutes, and that's because that character generator draws so much power, a few hundred watts. So we're going to dedicate one of these 1400s to just that character generator, use the rack mount 1500 for everything else in that room, and that'll balance out the load a bit and give us a bit more reserve capacity whenever the power goes out. So, one of these had no batteries in it when I got it. The other did have a set of extremely dead batteries in it, 0 volts, completely open circuit, totally bad batteries. But I have 4 new batteries. These each take 2 batteries, 2 massive 17 amp hour batteries. And I've got 4 new batteries. Unfortunately, the batteries had been sitting for years. Station manager bought them, never installed them. So they've been sitting for a few years, and they were low on voltage when I got them. So I currently have them sitting on a charger. Let me show you. Here's the 4 batteries. I've got them all paralleled up with alligator clips. They're about the size of a small lawn tractor battery. 17.2 amp hour lead acid batteries. And these are freaking heavy. The box of 4 of these, having to haul it up the stairs, I nearly died. The 4 of these put together, probably 50-60 pounds of battery. But anyway, I've got them all paralleled up, and I am charging them. They were all originally at 11.7 volts. Not good. That'll definitely reduce the life if they've been sitting at that voltage for a long time, which they have. But we're going to try and use them anyway, see if I can salvage them. I've got them paralleled up and charging on this car battery charger. I've had this thing for 10 years, and this is the first time I've ever taken it out of the box and used it. So I got them charging at the high current 6 amp setting, and it's humming away. Currently at a little over 13 volts. So I'm just going to let these do their thing, charge on this, and maybe by the end of the day they'll be fully charged and I can put them in the UPSs. So these are pretty neat. I like UPSs. I like anything related to backup power. UPSs, jumper packs, generators, anything. And these are some pretty cool UPSs. They've got a lot of intelligence on board. Load meter, battery meter, a test button which periodically takes it off of mains power, so you can test if your batteries are good and if it can handle the load and everything. We got status LEDs for the line voltage. So the middle LED means everything's good, line voltage is being supplied. This LED means that the line voltage is too high and the unit's automatic voltage regulating is compensating for it. And this LED means that the line voltage is low and the unit's using its automatic voltage regulation to compensate for that. That's a feature that the Smart-UPSs have. You can run in either of those conditions indefinitely without wear on the UPS, but of course if your line voltage is abnormally low or high, you might want to get things inspected by an electrician. These LEDs indicate the status of the battery and the inverter. This light at the top, I believe, means it's overloaded. The middle LED means that the load is being supplied by battery power, so there's been a power failure. And we have a light for if the batteries are bad and it's time to replace them. So these are pretty neat. They've got a lot of built-in functionality. Under that desk over there, I've got a, you can just barely see it there, I've got a back UPS 450. That's a basic, cheap UPS from APC, and it doesn't have any of this functionality. It's just got one single on-off button, and all the other functionality has to be from the computer. But even the computer program can't display all the information that the smart UPSs can right on the front panel. So these are pretty cool. They're very big, you can see, and extremely heavy. Even without batteries, these things must weigh 20 or 30 pounds. And with two of those giant batteries in them, they are freaking heavy. Very heavily built machines. Let me turn one of them around here and I'll show you what's on the back. Looking around the back, that's an honest-to-goodness serial port for communication with a computer. Connected to a computer, you can use software like APC UPSD, which is an open source piece of software for managing these UPSs. It'll even work on a back UPS with a USB connection. We can use this little button here to adjust how sensitive the UPS is to voltage fluctuations. Very nice. And we have an LED that'll come on if there's a wiring fault, like an open ground. And then both of these have this network management card. It connects the UPS to Ethernet, so you can manage it over a computer network. Now I think these UPSs were made in the early 2000s, because if I take out the card here, we can just pull the card out, and there's the Ethernet card, and it's copyright 2001, date code 2002. Any other date codes? I tested that coin cell battery. It's actually still good. Yeah, I see another 2002 date code on that chip there. So these were made probably around 2002. Well, at least this one is. I would assume these were purchased together, but I haven't actually bothered to check that. We have 6 outlets. I believe they're all connected to the battery backup, in addition to serving as surge protection. In newer smart UPSs, some outlets are only for surge protection, and some of them are for surge protection and connection to the battery pack, but all the outlets in this unit perform both functions. We got a resettable circuit breaker if the unit becomes overloaded. And this is a battery disconnect. It's got just a loop of really thick wire. And it's secured with these 2 screws. When you remove those 2 screws, you can pull this out to disconnect the battery from the rest of the UPS. That's really important because these things have enormous honkin' capacitors in them and an enormous honkin' transformer. And I have seen when you connect a battery to these things, it makes a loud snap and a big spark because of the inrush current. So the nice thing about these is pull this plug before you install your battery, and then after your battery is installed and hooked up, you can plug this in. So any inrush current, the spark is going to happen on this connector rather than right at the battery, which could serve as an explosion risk if that spark happens to ignite any hydrogen gas. Not a common occurrence, but a small risk nonetheless. And then you got your power cord. So move this aside here. These have built-in fan vents. I believe they run when the unit's on battery power. The thing with UPSs is, because they were only meant to run a relatively short amount of time, they weren't designed to be thermally efficient or to handle a lot of heat. So what some people will do when they get an old UPS like this is they'll hook it up to a car battery or something like that, give it some extra long run time. Unfortunately though, depending on your load, you do run the risk of burning out the inverter if you do that, just because the inverter isn't meant to run for such a long time. But these ones, they have a fan that runs in them to help a little bit. So to gain access to the battery compartment, the front panel actually comes off, pulls off like that. It's a bit of a two-handed job. There we go. And beware, because it's connected via a ribbon cable, so just flip it over like that. And then you undo two screws here. And the door flips open. And you can wedge it off of its pivot point. And that is where your batteries go. This is a connection to the batteries. I put all the battery connecting hardware in this little baggie. This was the one I took the old batteries out of that were no good. So these take two of those big batteries, and they're actually wired in series. This is actually a 24-volt system. So the batteries have an enormous 100-amp fuse, which you can see right there, that connects them in series. And then they have another connector that bolts onto them, because the batteries have those lugs that take a bolt. And then this is where your 24 volts goes across. And then back there is where the inverter and the rest of the UPS's electronics go. So about maybe 3/5 of the volume of this UPS is for batteries, and the other 2/5 is the inverter and everything else. And you can see those thick wires. Of course, being a 1400 volt amp unit, well, the 1400 model is 1400 volt amps, 950 watts. For the sake of math, let's round that up to 1000 watts. 1000 watts at 24 volts, 40 amps at full load. So yeah, these wires have to be very thick. So there's what's inside that and where our batteries will go later. And you can actually see they put the ratings on there. For the 1000 model, 670 watts. For the 1400 model, 950 watts. I think all there is to do now is wait for those batteries to charge. Come back later today and hook them up and see if these things work. It is 7 hours later. The batteries were still drawing plenty of current, but I've decided to take them off. They're all charged at 12.7, 12.8 volts, so that's plenty. If there's any more charging to be done, the UPS can do it itself. Let's unhook all of these from their parallelness and move them over to the UPSs and install them. Next, to prepare the batteries, we have two batteries facing each other like this. This is the 100 amp fuse that'll be connected right here to connect them in series, and then bolted on the other side is the connector that mates to the connector inside the battery compartment of the UPS, and that'll bolt on the other end, and what you get is a single 24 volt battery. Okay, fuse bolted in on one end, connector bolted in on the other end, and I'm going to take some tape and wrap the batteries together because they do move independently a little bit, and that induces mechanical stress on the fuse, I can see. So I'm just going to do that so the batteries stay put together and don't move relative to one another. Alright, both battery packs are prepared. It's time to bring in the UPSs again and hook these things up. First thing to do is remove this battery disconnect. I've already unscrewed the bracket that locks it in place, and then we just use this rope here. I suppose you could just grab onto it as well. Maybe that'll be easier. There we go. Just a single big loop of wire, and now the internal components of the UPS are disconnected from the battery lead, so when we put the battery in, we won't have a big spark because of inrush current. First thing to do is to hook up our battery terminals. Okay, battery terminals are connected. Now we just got to finagle the battery inside. and the backing plate slots in, and perfect. Now I just gotta screw it closed and put the cover back on. Alright, the last thing to do is swing this thing around, which is going to be really difficult now because this thing has doubled if not tripled in weight, and plug in that battery disconnect. Alright, moment of truth. I suspect that when I get this thing connected, the unit should come to life and start screaming because there's no AC power connection. Let's find out. Okay, it's actually not making any racket. That's interesting. Oh, maybe it defaults to being turned off. Maybe when I hit the power button, it'll turn on. Oh? I hope I can jump off this couch quick enough to pull the disconnect again if something goes terribly wrong. Okay, let's plug it in and see what it does. Okay, let's see what happens when we plug it in. I heard a relay, I hear a fan. I feel like there should definitely be lights on the screen, but there isn't. Oh, okay. Is that on and off? Or that must be off, that must be on. Okay. That says 80% battery. I'm not sure why the AC light's flashing. Oh, it's doing a self-test. Super loud inverter. I think we're good. I guess the fan runs all the time. I didn't know that. Batteries are charging. It's got no load on it. If I hold the test button, now it's on the battery power. And back on AC. Cool. Alright. So, the batteries aren't totally charged, but they're charged enough, I think, to run a real test of this thing. Let's put a load on it and see how it works. Alright, let's give this thing a shakedown test. I have plugged into it my air conditioner, which isn't the greatest thing to plug into a UPS. It's a high inductive load, but as you can see, it's only 40% loaded. When the compressor kicked on, it did briefly jump to 100% and the overload light briefly flickered, but then it settled down. But it's running now. Let's unplug the UPS and see how it does. Hey, if this thing's going to be running something as important as a $40,000 character generator, then we don't want to see it blow up just running a simple air conditioner. Okay. Air conditioner still running. Battery capacity remains at 80. Oh, down to 60%. I don't even hear the inverter. That's good. Look at that. She's running an air conditioner. Very cool. I don't even hear the compressor buzzing any louder than the air conditioner. Sweet. Well, this thing's a runner. Let's plug it back in. And we're back on AC power. That little stint robbed the batteries of 20% of their energy, but that's no issue. Alright, let's go a step further. I now have the air conditioner and a 150 watt incandescent light plugged into it. It's showing 60% load. Let's unplug it again. She is running. No problem. Battery down to 40% charge. Okay. Clearly it's passed that test. Plug her back in. And it's back on line power. It does really good voltage regulation. I didn't see the light dim at all, or even flicker or anything when it switched between AC power and battery power. So it does a good job of maintaining the output voltage. Very nice. Well, I would say this is a good unit. I'm gonna leave it plugged in, let it charge, and set up the other unit now. Alright, second UPS is connected and running, and it passed the self-test and everything. Batteries in this one are reading at 60%, and I'm going to give it a different kind of test. I have here a fan heater, my Seabreeze SF8 fan heater. I'm going to run it on the lowest setting, 500 watts. I did see what the load meter was running at the second setting, which is 1000 watts, and the load meter was at 100%. Overload light wasn't on, but I don't feel like testing this thing at 100% load and risking hurting the inverter. So I'm going to turn this on. You can see with just the fan there's no load at all, and then put it on the 500 watt and the load comes up to 60%. And this UPS is actually connected to this UPS, so I'm going to disconnect power to this one just by turning this one off, and let's see how it does. There she goes, running a 500 watt heater. Oh, battery power has gone down to 20%. The inverter is audibly humming. And she's complaining. We'll turn AC power back on. And that's it. Alright, well it looks like we have two good working UPSs. And I think those batteries are going to be okay too. So I'm going to leave these guys plugged in and turned on overnight, let the batteries charge, and then tomorrow these guys will go back to the television station and be put to use once again after being sidelined for however many years. Two nice American-made, really heavily built units. Very nice. So there you go. I hope you guys enjoyed, and I will see you in the next video.